There's this incredible hidden power source all around us. It's unleashed every single second right where a river flows into the sea. It's this massive, constant energy exchange. And for decades, scientists and engineers have been dreaming of how to tap into it. So today, let's dive into this amazing, unseen power.
Really think about that question. What if we could power an entire city just by mixing fresh water with salt water? It sounds like something straight out of science fiction, doesn't it? But it's not a fantasy. This is the core idea behind a really remarkable form of renewable energy.
So, what do we call this stuff? Well, the official term is blue energy, or sometimes you'll hear salinity gradient power. Basically, it's the energy we can get from the difference in saltiness between two bodies of water. You can almost think of it like a giant natural battery that's just waiting to be plugged in at every river mouth on the planet.
Now, this idea, it's not exactly new. It was actually first kicked around way back in 1954. But it took until the 70s for an engineer named Sidney Loeb to figure out a practical way to actually capture this energy. And his work led directly to the world's very first prototype plant, which opened up in 2009.
And get this for an origin story. Sidney Loeb was apparently inspired while watching the Jordan River, which is freshwater, pour into the insanely salty Dead Sea. He just saw that natural process happening and thought, wait a minute, there's a ton of energy being wasted here. So how in the world does this actually work? Well, the secret is a process you probably learned about in high school biology class. It all comes down to osmosis. If you can get your head around that one concept, you've basically unlocked the secret to how blue energy works. Okay, so in the simplest terms, water just wants to find balance. If you've got fresh water on one side of a special filter and salt water on the other, the fresh water is going to naturally try to push its way across that filter to dilute the salty side. This natural movement, this push, creates what we call osmotic pressure, and it is immense. This diagram shows it perfectly. So you've got your salt water on the left, that's W2, and your fresh water on the right, W1, and they're separated by that membrane in the middle, M. See those little arrows? That's the fresh water literally rushing across the membrane to even out the saltiness. And that action pushes up the water level and generates that incredible pressure, labeled P. Okay, so we've got this natural pressure. That's great. But how do you turn pressure into electricity that can actually, charge your phone? This is where the engineering comes in, and we go from a science experiment to a full-blown power plant. So the most common method is called pressure retarded osmosis, or PRO. It works like this. First, you pump seawater into a chamber. Then you let fresh water rush in through those special membranes we talked about. This flood of new water dramatically jacks up the volume and the pressure inside that chamber. And what do you do with high pressure water? You use it to spin a turbine. And that turbine, just like in a hydro dam, creates electricity. Simple as that. And here's what that looks like in a simplified drawing. You can see the intakes for the freshwater and the seawater. They go into that membrane system. That's where all the magic happens. And the high-pressure water that comes out drives that turbine generator. It's actually a pretty elegant way to turn a natural chemical process into raw power. Now, PRO isn't the only game in town. There's another approach called reverse electrodialysis, or RED. And the easiest way to think about this one is that it's basically creating a salt battery. It uses different kinds of membranes that separate the salt ions to create an electrical voltage directly. No turbine needed. So, the science makes sense, right? The potential seems huge. But what happened when we actually tried to build one of these things in the real world? Well, this is where the story gets a little more complicated. And here it is, the world's first ever prototype. It was built by a big Norwegian energy company called Statkraft, and it opened back in 2009. This was a huge deal, a massive leap from just theory to an actual working plant. And you better believe hopes were incredibly high. And why were hopes so high? Well, just look at this number. Statkraft did the math and figured out that the theoretical potential for this kind of power in Norway alone was 2.85 gigawatts. That is a staggering amount of clean energy. We're talking on the scale of multiple nuclear power plants. But then, reality came crushing in. The plant's actual output when it started, just 4 kilowatts. To put that into perspective, that's barely enough power to run a big electric kettle. So you had this huge, grand potential on one side, and this tiny, practical output on the other. And, well, the writing was on the wall. In 2014, Statkraft pulled the plug. They shut the whole project down.
Their conclusion was that the technology, as it was, just wasn't economical. The biggest problem? The membranes. They just weren't efficient enough to make electricity at a price that could compete.
But hold on, the story doesn't end there with a fizzle. That big failure, that membrane problem, it actually sparked a whole new wave of innovation. People started asking, what if we could build a better membrane? A much, much better one. And that's where nanotechnology comes in. Right now, researchers are working on membranes made from something called boron nitride nanotubes. These are unbelievably tiny, super efficient tubes that let water molecules zip through way faster than any of the old tech. Okay, now get ready for this, because this comparison is the potential game changer. Remember the entire Statkraft plant? It produced 4 kilowatts. Well, projections for these new nanotube membranes suggest they could generate about 4 kilowatts from a single square meter. Not the whole plant, 1 square meter. That is just a mind-boggling leap in efficiency. Of course, with any kind of power, we have to ask the big question, what's the environmental impact? And blue energy has some really clear upsides, but it's not a complete free lunch. There are some real challenges we'd have to figure out. So on the plus side, it's totally CO2 free, and the fuel, freshwater and saltwater, is completely free. But the main thing it produces, besides electricity, is brackish water, that mix of salt and fresh. Releasing huge amounts of that could mess with local ecosystems. And you'd need big water intakes, which could pose a risk to fish and other marine life, kind of like other coastal power plants. So that brings us back to the big question. With this absolutely massive potential and now the promise of new nanotechnology, is blue energy about to become a giant in the world of clean energy? Or are the economic and environmental hurdles just too big, leaving it as a cool idea that never quite makes it? The future of this amazing technology might just depend on what happens inside those tiny, tiny nanotubes.